Hi guys, I hope you're good since the last video. DeepSeek Labs. At the beginning of the year, they brought this distillation paper. Now they're bringing a new paper, DeepSeek-OCR. Optical character recognition. But for them we can call it optical compression and recognition. We will be explaining what it's all about. I'm gonna try to run it on my computer. I tried, but it didn't work, but I'm going to show you how you would modify the code in order to try yourself. DeepSeek Labs, limitless creativity. So when we're performing traditional retrieval, there is a human request. The model has a lot of work to do. Extract from the context the embedding vectors. There is more token involved. We got here in the scenario a PDF. From the PDF you want to get some information, so you're asking to the LLM to answer to your questions. Text extraction only, it's okay, but it's very difficult for graphs and images in combination with text to get this running efficiently, properly. So here we get the human request. We can call it the RAG system that you already heard about, the Retrieval-Augmented generation. So that's what we used in the channel. That's what we've seen. So now let's go in this scenario where we have a PDF, very complex, and we want to retrieve the details. Let's go through first the problematic, which is for a document containing 1,000 words, how many vision tokens are at least needed for decoding. The solution, a picture, is worth 1,000 words. We're going to see the concepts through just keywords, low activation, few vision tokens, dynamic resolution, Gundam style mode, geometry for graphs, no HTML, and a lot of in-house recipes that you can find in the paper, or maybe not. They're talking just about it. So here, the document, let's just see what we have here as an example from the paper. You have a PDF, complex one with images, paragraphs, text, title, subtitle, and you can see here it has labeled and recognized every single part of the document, saying paragraphs, saying this is an image, this is a title, and so on. So image input, result, and after here we have the deep parsing. So we get image input, result, and here deep parsing, and after we get the rendering, where the LLM is going to explain what it's all about, what is the paragraphs, and so on. So this is the example. We're going to focus more into the deep encoder. That's what I found the more interesting part of the paper. But in the other side, same as the RAG, we have user request asking to a model to interpret some information, passing through the deep decoder. So that's what they use, but we're focusing on the deep encoder. We have our PDF having text, graphs, and images, like here. Complex document to interpret. So the technique is actually to take this as a picture and to cut it in pieces 16 by 16. That's how they do. So this is something that is not done usually. It has been done in the past, but put on the side. So they get 16 by 16 chunks, and also those chunks, they have a kind of neighboring. They know the context of what is around them. So that's how we can maybe do this relationship between those different chunks. So it doesn't want the U, but I'm gonna leave it with a U, with neighbor relations. Okay, like the closest. So you get your PDF. The PDF is broken into small chunks, 16 by 16. This is the extraction after we have the tokenization. Each piece is transformed into a vector, mathematical vector with a certain dimension, 256 in dimension, and after that there will be a compression. So here I put compress, here I put just a recap of everything so that you can understand. I call it compress story. So 16 by 16 images. After that, we get an increase from 256 dimension to 1024 dimension. After that, there is a bigger sequence length. So I put here dimension, but this is 4096 encoding sequence length. And after there is a compression back to 256 dimension before attention. This is just to save some compute, some memory. So the optimal setup is to compress it 10 times for 97% precision. So we can go back maybe to the keywords. Low activation means uses fewer neurons to save compute. Gundam mode, the Gundam style mode, compact processing configuration. So compressing image tokens reduces costs and speeds up inference without losing much accuracy. Faster, cheaper, and smarter document understanding. So this is, in a nutshell, what is the paper about. Let's have a little break. Please like and subscribe and support the channel. Git repository, DeepSeek-OCR. I'm just going to show you what I went through, trying to modify the code for my CPU-only computer. If you have GPUs, I believe that you can run it. But I found it interesting because we tried to train a model in the past. And you're going to see here that I'm going to just focus on the part of the code where they're using the Hugging Face code. That's the same code that we have used during our training. So that's why I found it interesting to show this part as well. So I'm just making here a directory, DeepSeek-OCR. After that, I'm going to clone the repository. After, you're going to create the Python environment. So there's a lot of file in this repository. But you can just go to the Hugging Face one if you want to run it locally and you have GPUs. We activate the environment, and after we're going to install some of the requirements. You can install the setup tools. You need also to install Torch for CPU. And after we're going to try, we're going to modify now this file. So you can put the image file that you want. You're going to deactivate whatever it's CUDA. CUDA means GPU. So we want only CPU. There's no attention. You can add eager or you can just comment it out. The torch type, you can add it to torch float 32 for CPU only. So you can't use 16 or 8. And after for the model here, you just eval to torch device CPU. That's what basically you need to do to change your file. Okay, so I've tried to run it locally, but it failed. I could download the model, but after doing the inference it didn't work. So if you have nice GPUs, just go for it and try using the GitHub repository. So we have less cost, faster insight, and smarter, very complex document reading, especially for graphs and rich layouts. Replaces text-only RAGs with a vision-aware deep encoder and deep decoder that compresses images data into fewer tokens. We will see how this is going to evolve and how other AI firms are going to respond to that, as it has been put on the side for a while. So that's a technique that has been tried before, but now it's coming back. So when now context length is and token consumption is crucial, we might have probably found here a way to scale up the number of data that can be interpreted by an LLM. Okay, let's stop here. Please like and subscribe, and see you next time.